All right, we're gonna draw these Lewis structures, and I'm gonna do them really quickly. If you have questions on any specific ones that you wanna see more detail or more slowly, please post on the discussion board. You have to have the correct Lewis structures in order to do the second part for your bonding lab and the third part. So make sure you check your Lewis structures before you turn in your bonding part 2. All right, so CH4, this one is pretty easy. We draw a skeleton. We count up valence electrons. You're going to look at a periodic table to see that carbon has 4. Each hydrogen has 1. So that's 8 total. And once I've drawn this structure, there are the 8 electrons. There's the Lewis structure of CH4. All right, H2O. Oxygen is in the center. Hydrogens are attached. Oxygen has 6 valence electrons. Hydrogen has 1. And there are 2 of them for 8. So there are 2, 4 already added. 6, 8. There's the Lewis structure for H2O. Hydrogen does not want 8. It's an exception to the octet rule. H3O plus. That has the oxygen in the center with 3 hydrogens. Oxygen has 6. Each hydrogen has 1. That makes 9, but the plus charge, we really should put brackets in a plus charge. The plus charge means it's missing an electron for 8. 2, 4, 6, 8. There's the Lewis structure for H3O plus. All right, NH3 and NH4 plus. NH3, nitrogen in the center, 3 hydrogens. Nitrogen has 5, each hydrogen has 1, for 8. 2, 4, 6, 8. There's the Lewis structure for NH3. NH4 plus, nitrogen in the center, 4 hydrogens attached, brackets and a plus sign. Nitrogen has 5, each hydrogen has 1, for 9, but I subtract 1 for the charge. 2, 4, 6, 8. There's the Lewis structure for NH4 plus. All right, let me grab this. Oops. And bring it down here. Okay. Now we're ready for CCl3F. Carbon is in the center. There are 3 chlorines and 1 fluorine. All right. Count up your valence electrons. Carbon has 4. Each chlorine has 7, and there are 3 of them. And the fluorine has 7. 7 times, use your calculator if you need to. I'm going to use my calculator just to double check. 7 times 4 is 28. Plus another 4 for the carbons, I get 32. 2, 4, 6, 8 have already been added. And so I have 24 remaining electrons to add. I'm going to start with the outside, adding them in lone pairs. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Let me clean that one up a little bit. So that's the Lewis structure for CCl3F. It's got a lot of lone pairs on the outside atoms, but as you move into the next part of the activity, you're going to be focusing in on the carbon. You actually were focusing in on the carbon up here, actually down below. Let me open up that. When you wrote out CCl3F and you got the Lewis structure, the question here is number of groups on the central atom. And there were 4 groups there, no lone pairs, 4 bonds. So CClF looks like this. Copy. Paste. All right, CCLF looks like this. Four pairs on the central atom, bonding groups on the central atom. All four are bonding, and so that's a tetrahedral. All right, so getting that Lewis structure as you move into the next part, you got to look at the central atom to answer those questions, and I'll let you finish that one up, but that gets you started on this one. All right. Next, CO2. Bring it down here. All right. CO2 has carbon in the center and an oxygen on each side. You could put them up or down, left or right, that doesn't matter. Carbon is 4, oxygen is 6 times 2. That's 24, 28. Nope, that's not right. Always use a calculator to double check if you need to. Don't miss the problem because you did the math wrong in your head. That's my motto. 16. We've already put 4 here in the skeleton, 2, 4. So we've got 12 left. 2, 4, 6, 8, 10, 12. The problem is that the carbon does not have his 8 yet. So we're going to take some outside electrons and move them into a double bond. We'll do so on each side in order to give carbon its octet. And so the Lewis structure really has a double bond between the carbon and each oxygen. There's CO2. All right. CO3 with a -2 has 3 oxygens, and it's all got a -2 charge. So carbon has 4, oxygen has 6 times 3, 18, 19, 20, 21, 22, but I'm going to add 2 electrons for the charge. -2 means he has an extra 2 electrons. So there will be 24 there when I'm finished. 2, 4, 6 have already been added. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. That's all my electrons. But notice that carbon doesn't have his octet yet. He's not happy. So I'm going to put a pair into a double bond with carbon. Now, which oxygen I choose to do this with doesn't matter. Technically, this has resonance. There are 3 resonance structures with the double bond resonating between carbon and each oxygen. But this structure will allow you to be able to answer the questions for the part 2 and the part 3. So this is your beginning Lewis structure to get those answers. All right. Come down here. Let me add another page just in case we need it. All right. So now I'm ready for O3. That's 3 oxygens in a row. Each oxygen has 6, so that's 18 electrons. We see some patterns here with some of these. Once you've done a Lewis structure and figured it out, you can do a bunch of similar ones. That's the beauty of this. All right, 2, 4 have already been added, which means I have 14 left. 2, 4, 6, 8, 10, 12, 14. And I have to stop because that's all the electrons I have, but the middle oxygen isn't happy yet, so let's take a pair and put into a double bond to make him happy. Now I could have done the right oxygen, I could have done the left oxygen, that doesn't matter, but that means there's resonance. You should draw 2 resonance structures for this with a double bond in both places. But for the next part of the lab experiment, this structure will get you the right answers. All right. SO2, sulfur with 2 oxygens, sulfur 6, oxygen 6, 18. Look how similar this looks to the other guy. I've already added 4, which means 14 remaining. And if we go through the exact same process, we end up with exactly the same spot. We end up with a double bond between the sulfur and oxygen, but it doesn't matter which oxygen. which means there really needs to be resonance structures. But this structure will get you the correct answer for the next two experiments. All right. SO3, sulfur with 3 oxygens, sulfur 6, oxygen 6. That's 24. Looks a little similar to something we've already seen. I end up with, if I look, he looks just like, remember this carbon dioxide that the CO3 with a -2? Notice how we ended up with 24 total electrons. We're going to see a structure very similar to that. So here we go. We've already added 6, that's 18 remaining. 2, 4, 6, 8, 10, 12, 14, 16, 18. Make a double bond. There really needs to be resonance, but you don't have to draw it to get the next part right. SO3 with a -2 looks very, the skeleton looks similar. All right, SO3 with a -2. The only thing is there are an extra 2 electrons. So sulfur is 6, oxygen is 6 times 3 for 24. But I'll add 2 electrons for that -2 charge. -2 means an extra 2 electrons. So I'm going to be adding 26 total. I've already put in 6 with the bonds. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That makes everybody happy with 8. There is your Lewis structure for SO3 with a -2. All right, let's keep going. We're almost done. N2O, the atom arrangement is NNO. That is the skeleton. Nitrogen is 5, and there are 2 of them. That's how many valence electrons he has. Oxygen has 6 for a total of 16. I've put 4 already in the skeleton. That looks similar to something we saw above. I have 12 to add. I'm going to go 2, 4, 6, 8, 10, 12. But my nitrogen in the center isn't happy, so I'm going to need to start making double bonds. We saw that with CO2 above. Pause the video and go look at CO2 above. And so you end up with something like that. Now here's a tidbit. Here's an aside. That's not actually what the Lewis structure of N2O looks like. It actually looks like that. We know this from experimentation. The left nitrogen, the left in the way that I've drawn it, shares a triple bond with the center, and there are no multiple bonds with the oxygen. But either one of these Lewis structures will get you the right shape as you're looking on the next part, part 2. Look back at your assignment for bonding part 1. If you missed this question because you had the top one and not the bottom one, I'll give you full credit for it. I may go ahead and go look at that right now after I finish this video. All right, so that's one that you wouldn't necessarily know whether it's the top one or the bottom one based on what we've done in class, unless you Googled it. And if you Googled it, then you got the bottom one. But I would give credit for that top one. I may go look back at that. All right, PCl3. Phosphorus in the center, 3 chlorines. I'll make a chlorine better. Phosphorus has 5. And by the way, you know how I'm getting these number of valence electrons so quickly, right? Right? If you don't, post on the discussion board. That's 26 total. This may look similar to something we saw above, which means I have 20 remaining. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's the PCl3 Lewis structure. SF2. Sulfur has 6, fluorine has 7 times 2. That's 20. I've already added 4. This is looking a little familiar maybe. 2, 4, 6, 8, 10, 12, 14, 16. Actually, I think this is the first time we've seen one like that. There's the SF2 Lewis structure. And then the last one is BCl3. This is an exception. We see an exception to the octet rule here. Boron, if you look at him on the periodic table, he only has 3 valence electrons. Each chlorine has 7, which makes 24 total. And I've already added 6, so I have 18 remaining. If you add the 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, you end up with this. And if boron really wanted 8, I would put a double bond there. But boron doesn't want 8. Boron is an exception to the octet rule. He is perfectly happy with 6. So I leave these at single bonds. Again, if you Google this, Google will give you the right answer. I don't form a double bond to give boron an octet. And again, I may go look at your answers on part 1 and see if anybody accidentally put a double bond there, and I'll give you credit for it. But that's what we have for all the Lewis structures. You do need these for part 2, so be sure to check all of yours and use the correct Lewis structure to answer the questions for bonding part 2.